Okay, hello everyone. Right, sorry I can't be teaching you. Obviously, you guys are at home at the minute. And rather than just set you some work, I thought I'd introduce it. We've been through the waves topic so far, and we're going to move on to the second half of the topic on the last little bit, really, called electromagnetic waves. So, if we pop into revision, physics revision, I'm just going to take you through the topic support packs. We're going to have a quick look at the waves one to give you a bit of an overview as to... Oh, I've downloaded a copy. Just go in. View. There we go. View. Wonderful. This gives us a bit of an overview on what we've done so far. So if we have a quick look from top to bottom, explain the difference between transverse and longitudinal waves. Can you remember them? That's important for this. That is waves, transverse waves, like the letter T, are waves where the oscillations are at right angles to the direction the wave goes. So if you think of a water wave, it goes across a pond, but a little duck on top, indicating the motion of the oscillations goes up and down. So that's at right angles to the direction. Longitudinal waves, the energy transfer is in the same direction as the oscillations. That's like sound waves moving backwards and forwards. We then introduced a couple of equations. The time for one oscillation is equal to 1 over the frequency. Frequency is measured in hertz. We looked at amplitude, which is the size of the oscillation from the middle of the wave to the top of a crest. Wavelength is from crest to crest, or compression to compression if you're talking about longitudinal waves with their little bits of compressed waves. Then we looked at the wave equation, which is speed v equals f times lambda. Lambda isn't written very well there for some reason. It's not shown up. So wave speed is equal to frequency times wavelength. We don't need to worry about the bits that say physics only. So we're then on to the remaining bits, and we're not going to do too much on higher tier because we're focusing on foundation. So we only have a little bit of these bits here where it says refraction of a wave. We'll do that separately. But describe the electromagnetic spectrum, explain the hazardous effects of UV, X-rays and gamma rays at the bottom, and explain how changes in atoms and nuclei result in the generation of EM waves over a large frequency range. That'll become more obvious in a second, and then describe the practical uses of each type of radiation. So you're going to do that over the course of the next couple of lessons. So if I just introduce what you're going to do whilst you're off, here is, we're going back to the physics section now, and we're going to go into the waves topic, and I'll show you what I'd like you to do. I'll do a quick introduction as well, so you're not all completely left on your own. So we're into physics now, and we go into properties of waves. We're going to go into the electromagnetic spectrum. I'd like you to ignore the top bit. We're going to look at the electromagnetic spectrum here as soon as it loads up, which it should do in a second. There we go. Well, you've got this diagram here, which is kind of your go-to point of everything, but it needs a little bit of an explanation. So I'm going to very quickly switch to this here. Electromagnetic waves are oscillations in the electric and magnetic field. So if we have a magnet around there, or if I have a wire with an electric current I flowing up it, around there you have a magnetic field around the bar magnet, which goes from north to south, and North Pole will go, so you've got a little magnetic field around there. And around a wire we would have an electric field. Now, an electromagnetic wave is an oscillation in that field, so it's the field itself changing. And to give you a bit of a visual explanation on that, if we go to this PowerPoint here, I wonder if the animations are going to work. Oh, no, they're not, unfortunately. But we have the blue and the red, which is indicating the electric and magnetic field, and how you can see there's a wave shape there of the red, and a wave shape there of the blue. That is the electric and magnetic field, and it's all around us. You can't see it, but it is an electric field around us. If we go back, and this PowerPoint here kind of indicates that it's not going through matter, so it's not classed as a mechanical wave, but the oscillations are perpendicular to each other and the direction the energy goes. So it is a transverse wave, but it's not through anything. It's just this magnetic field around us. Now, if we head back, we could consider the wave itself to be a wave of lots of different potential frequencies. Now, we could have oscillations in that magnetic field that are very, very frequent or not very frequent. The case of all electromagnetic waves, they all travel at the same speed, and that speed is called the speed of light, because light is an example of an electromagnetic wave. It has a particular frequency around 10 to the -6, so 0.5 times 10 to the -6 of a meter. That's the wavelength. So it's a very specific small narrow band, and our eyes pick up on that. And the speed of light travels at 300 million meters per second, and in standard form that's 3 times 10 to the 8 meters per second. Now, light travels at that speed, but also so do all of the other sections of the electromagnetic spectrum, from radio waves, which are low frequency. Oh, hang on, the TV's just came on. Bear with me. Comedy gold. Let's turn it off. So radio waves, which have a long wavelength and low frequency, all the way up to gamma rays, which have a very small wavelength and very, very high frequency. They all, however, travel at the same speed. They cover the same amount of distance each second. It's just some are oscillating at a great frequency and some are oscillating at a lower frequency. What I need you to do is to learn about each of these sections, from radio, microwave, infrared, visible, which I've covered up there, ultraviolet, X-ray and gamma rays. You need to know all about them. You need to know roughly their frequencies, roughly their wavelengths, but more importantly, what their uses are. Now, you can go through this presentation here and it'll go through a few kind of visual hints. If I come back as well out of here, really good thing to watch is this ridiculously bad electromagnetic spectrum song. It's terrible, but it'll stick in your brain and you'll be able to remember some of those electromagnetic spectrum bits. Great link there, but here is the table I need you to work on. So download that. If you've got a printer, print it off. Otherwise, download it to your iPad. So save it to books and you can write your notes on there. It basically is going to ask you to go through and make notes on each of these electromagnetic spectrum sections. But where do you get the information from, I hear you say? Well, you've got all of this, you've got the song, you've got the link just there, you've got the PowerPoint to go through, you've got the picture, but really importantly, we have the GCSE pod video links. Now, if you go onto here, this will take you through to some of the video GCSE pod pages. Now, depending on when you've logged in last, that hopefully should let you in. If not, you're going to maybe have to go to resources, go to GCSE pod and find electromagnetic waves in the science section. Dead easy to find. One other thing, you can have a look at some of the work that the students in the other class have put together, and that is an information on each part of the spectrum, so you can use that to make your notes. I would expect in this case it would take you probably the rest of the lesson that you have so far, so about 50 minutes, because I've been waffling for a while, to complete that table there. What I'll then do is I'll set a couple of other bits next time, which will be to maybe finish that up, maybe answer a couple of questions and just to see how much you picked up. But try and make sure you know what their uses are, their applications, but also go one step further and look at the dangers, especially for the high frequency ones down the bottom of gamma, X-ray and ultraviolet. Okie dokie, get that done, and if you could, I will set that as a little task to upload a picture of the work that you've done. Okay, thanks.